Hello, my name is Tiggy, and today for my chemistry culminating assignment, I'll be discussing Module 2, naming organic compounds with multiple functional groups. Alright, so for this presentation, we'll be first going through a review of the functional groups and general naming scheme of all organic molecules. And then after that, we'll be going through a specific naming guide for each functional group, and with examples included as well. And then lastly, we'll be discussing large organic molecules, so I'll do a large problem, which we'll take up and work through after. So for this first part, we'll be talking about functional groups and the naming guide. Alright, so this table distinguishes some of the functions we'll be talking about for this presentation. So at the top of the list, we see the hydrocarbons or the alkanes, alkenes, and alkynes. Then we have the alcohols, the hydroxyl group. Then we have the ethers and esters paired together with their oxygen group here. Then we have the aldehydes and the ketones with their carbonyl group, CO double bonded. And then we see the carboxylic acid group. And then we have the amines and the amides, the nitrogen group here. And those will be the groups we'll be talking about today. Alright, so moving forward now in the naming basics. So to name organic molecules, first step to do is to name the longest carbon chain. And to do this, we have to see how many carbons long it is, and we would give it its designated carbon stem name. So for one here it would be meth, and then two would be F. Those are some examples. We also want to identify the highest priority functional group. Over here we see IUPAC name priority. Giving an order from bottom where it's the least priority to highest with the highest priority. Then we number the carbon chain from the lowest to highest based on the priority group, where the priority belongs to named at the lowest carbon. And then also name and define constituent groups in that chain as well, and identify them in the name of the organic molecule. For this next part, we're going through naming functional groups and the organic molecules. Alright, so the first one we're talking about right now is the alkanes. They're often regarded as the parent functional group, and with the root suffix of ane. So for the example here, we're practicing the naming system. We would first name the longest carbon chain, and here we see it's 5 carbons long, so with the prefix pent. And the highest priority group here would be the alkyl substituent over here, almost with the alkanes. And therefore we see the methyl group would be on the third position of this molecule. And the name of this one would be 3-methylpentane, designated the location on the main parent carbon chain. Now for the next hydrocarbon, we have the alkenes. Their suffix ends with the ene, and they have a double bond in their structure. So as you'll see here, once we go through the naming scheme of the 5, we have 10. There's no substituents, it's just the alkene group. We'll finish off with pent1-ene, where the parent ending is removed for the suffix of the alkene. So for this last hydrocarbon, we have the alkyne functional group. They have a suffix of the ine features in their distinguished triple bond between carbon to carbons. So for this example here, we see that the longest chain is 4 carbons long for the prefix of bu, and the highest priority group is the alkynes, and since there are no substituents, we find that the final answer is bu2-ine. For this next functional group, we have the halides. So halides act as substituents on the molecules of this prefix, and they include all the halogens such as chloro for chlorine, fluoro for fluorine, and bromo for bromine. So for this here molecule right here, we see the longest chain is 4 carbons long for bu. And to determine the highest priority function, we go by the alphabetical order. So therefore, chlorine would be prioritized as the highest. So we see we would name it as 2-chloro and 4-fluoro on the 4th carbon. And we get a final answer of 2-chloro, 4-fluoro-butane. For the next function, we have the alcohol. Alcohols have the suffix of -al, and they're unique for the hydroxyl group here. So when we go through the naming process, we see the longest chain is 5, so therefore we have 10. And the 5-party group group here would be the hydroxyl group here. And we see this is at the 2 position over here. Therefore we name it pentan 2-ol. So for the next functional group, we have the aldehydes, and they have suffix of the al with a carbonyl or aldehyde group. So going through this example now, we see the longest chain here is 3, so propane. And then we see the highest priority functional group is aldehydes. And just to note here, aldehydes always remain on the first carbon. And we see there's also a substituent group here with the methyl at second position. So you see the final result, we get 2-methylpropanol. So for the next functional group now, we have the ketones. Similar to the aldehydes, ketones have a carbonyl group, except the oxygen is bound to a carbon that has 2 R groups attached to it, and the suffix is -one. So going through this example, we see the longest carbon chain is 4 long for bute. The highest priority goes to the ketone right here on the second position. And we also have another substituent here, the alkene on the third carbon. Give us a final result of bute-3-ene 2-ol. Now for the next function, we have the ethers. This function is more complicated than other previous functions discussed. So for the ether group, it comes with the prefix of oxy. So this has a unique name system of the alk-oxy-alkane for the total molecule. And so essentially, the functional group is split between an oxygen atom, 2 R groups, and whichever side on the oxygen has the longest carbon chain is considered the parent molecule. So for this example here, we see the parent here is this propane, which has 3 carbon chains. And we see the highest priority goes obviously to the ether over here. However, on the other side, we see there's a less carbon chain, which was just 2 long. So therefore, we would attach it to the parent name, name it F, with F2-oxy, with 2 distinguishes the position of the ether on the parent. And we also see there's a methyl substituent on the second carbon position as well. So the total name would be F2-oxy 2-methylpropane. So for the next function, we have the esters. Similar to ethers, they have also a split naming system of the alkyl alkanoate. Except for these functional groups, the chain bond to the CO bond is always considered the parent, and the chain bond to the single standing oxygen is also considered the substituent. So for this example here, we have the parent will be named as F, as seen over here, 2 chains long. And to note that the double bonded carbon and oxygen is also on the first carbon group. And then we also have the substituent group here, also 2 long for ethyl. We get a final answer of ethyl and OA. So moving on, we're now about carboxylic acids. This functional group follows a more traditional route similar to aldehydes. So therefore the position of the functional group will always be on the first one, suffix of oic acid. So going through this example, we see that the largest chain is 2 long for F. Highest priority goes to the carboxylic acid. Since they're substituent groups, we know that the final answer will be ethanoic acid. The next function we're talking about is now the amines. Amines have nitrogen attached to an R group and typically bonded to 2 hydrogens as well. This function can be named in 2 separate ways of a suffix or a prefix. So going through this example here, we see the longest carbon chain is 3 carbons long, naming of prop. And we also see the highest priority functional group is the amine over here, or also amino. We see also there's also a substituent group here of methyl at the second position as well, also with the amino at the second position. So therefore, the 2 naming schemes can either be 2-amino 2-methylpropane or 2-methylpropane 2-amine. Alright, so last we have the amide functional group. Their system of naming is similar to the ester naming system, where we have the carbonyl group as always be the parent on the parent chain. We also have the nitrogen group over here, which acts as a constituent group. So working with this example, we see that the name of the longest carbon chain has to be on the carbonyl group, where over here we have 2, so therefore be F. And then the highest priority also goes to the amides here. And then for the substituent groups, we see here on the nitrogen group, there are 2 empty substituents of methyl. And when we would write the name of it, we would designate each substituent group as an N to indicate that there is a missing hydrogen from that position. And for the name, we would get NN dimethyl ethanamide. Now to the final test of looking at the complex molecule problems. Now for the first problem, I'll give you a chance to pause the video, attempt naming the molecule yourselves. Alright, so for the first step to solve this problem, we'll have to name the longest chain. Which here we'll see it's 6 carbons long, and we'll get the prefix of hex. Next, we have to find the highest priority functional group. We see here is the aldehyde group, so therefore we know the first carbon will always start where the aldehyde is. Let's rename it 1 through 6, straight down. Next, we can see the constituent groups here, and we see yes, there are 5 alcohol constituent groups on the 2nd to 6th carbons. And then now, when we name it, we see that the final name we get is hexane 2, 3, 4, 5, 6, pentanol dash al, which is also another name for alpha glucose, which is a molecule found in your body when you're processing foods through your metabolism. Now for the second problem, I'll give you a chance to pause the video and attempt naming it yourself. Alright, so for the final problem, first step is to name the largest carbon chain, and here we see it's here, 8 carbons long, and we see the prefix would name it oct. Next one, the highest priority functional group. Well, we see here the highest priority would just be like the alkyls, substituents over here, and the alkane. And location of substituents we see are at the 1st and 5th carbons, naming it from the lowest carbon to the highest. Get a final answer of 1,5-dimethyl octane, which is also used in fuel for industrialization uses and for fueling large automobiles as well. So that now concludes my presentation. Thank you again for making it through this lengthy presentation. Here's my works cited. Yeah, thank you.